we present a lesson on computer organization and architecture. In this lesson, we will describe the functional organization and architecture of a von Neumann computer. Who is John von Neumann? Let's find out. John von Neumann was a brilliant scientist and mathematician. He made an important contribution to the development of computers. He helped to design the way computers work. Before von Neumann's idea, computers were big and heavy, and they could only do one specific task at a time. Von Neumann came up with the new idea called the von Neumann architecture. Computer architecture is like a blueprint for a computer. It defines how all the different parts of a computer work together. It is the basic design that makes computers function. Just like an architect designs a building, computer architects design computers. The designs determine how fast the computer will be, how much memory it will have, and how it will process information. To explain von Neumann's architecture, let us liken a computer to the human brain. Just like the brain has different parts that work together, a computer has different parts too. The von Neumann architecture is like a blueprint for how a computer is organized. Here are the main parts. 1. Control Unit, CU. This is like the general manager of the computer. It directs the other parts what to do and when to do it. 2. Arithmetic Logic Unit, ALU. This is the mathematics and logic center. It does calculations like adding, subtracting, multiplying, and dividing. It also makes decisions based on comparisons. 3. Memory Unit. This is where the computer stores information, like numbers, words, and instructions. It's like the brain's memory. 4. Input, Output, I/O devices. These are the ways in which the user interacts with the computer. Examples include the keyboard, mouse, monitor, and printer. How do the various parts work together? Let us liken the process to following a recipe to prepare a meal. The recipe, which is a set of instructions, is stored in the memory. The control unit reads the instructions, one by one, and sends them to the ALU to be carried out. The ALU does the calculations or makes decisions. The input-output devices enable the user to give instructions, for example, typing, and see the results, on the monitor or the screen. So, the von Neumann architecture is a simple but powerful way to organize the parts of a computer and enable it to perform complex tasks. This is von Neumann's architecture. There is the processor and the main memory between which data and instructions flow. Then there are the input and output devices that enable the user to interact with the computer. Input devices enable the computer to receive instructions from the user. Output devices give or display the results after processing. The secondary storage is used for holding data and programs. Within the processor, there is the arithmetic and logic unit, ALU, and the control unit, CU. The ALU carries out the instructions. There are also memory registers for carrying out tasks. What is the Fetch-Decode-Execute Cycle? Let's find out. To explain the Fetch-Decode-Execute cycle, let us liken it to the process of preparing a meal. Just like a chef follows steps to cook a meal, the computer follows steps to complete tasks. This process is called the Fetch-Decode-Execute cycle. Here is how it works. 1. Fetch. The computer, like a chef, first needs to get the recipe. It fetches the next instruction from the computer's memory. 2. Decode. The computer then reads the instructions to understand what it needs to do. This is like the chef reading a step in the recipe. 3. Execute. Finally, the computer carries out the instruction. This is like the chef following the steps, for example, adding ingredients and mixing them together. The computer repeats this cycle over and over, very quickly, to perform all its tasks, from running games to browsing the internet. It's a continuous loop of fetching, decoding, and executing instructions. Thank you for watching. Goodbye.